Okay, so here's the agenda for today's webinar. First, we will go over objectives for the webinar. Then, after a brief introduction to the sampling guidance for unknown contaminants in drinking water, we'll walk through some of the key sections of the document so you can get an idea of how it can help you respond to incidents you may face in the future. And finally, we'll wrap up with next steps. So to start out by setting out objectives for the webinar. Upon completion of this webcast, we hope that you will have an understanding of the contents of the document, Sampling Guidance for Unknown Contaminants in Drinking Water. Begin to understand your organization's current limitations and identify ways to become better prepared. Understand the benefits of preparing and maintaining sampling kits. Be able to supplement existing emergency response plans and be aware of available resources and tools. So, EPA's Sampling Guidance for Unknown Contaminants in Drinking Water is a guidance document that sets out procedures for collection, preservation, and transport of drinking water samples that contain unknown contaminants. The guidance extends to pathogens, chemicals, toxins, and radiochemicals, and it supports multiple analytical approaches to detecting and identifying contaminants. It can be used for baseline sampling, routine monitoring, incident response and remediation, or decontamination operations. The primary intended audience of this guidance document is drinking water utilities, but it may also be a useful reference for emergency response personnel, laboratories, and other response partners, as well as wastewater utilities. The goal is to help sample collection teams develop proficiency by incorporating these methods into routine or baseline monitoring and remediation or decontamination efforts. The document can be used as a reference and is intended to supplement existing utility sampling policies and procedures. So let's take a quick look at the table of contents to understand what the guidance offers you. Section 1 is introductory. Section 2 gives an overview of the recommended sampling approach. Section 3 covers utility roles and responsibilities, including sampling for baseline monitoring and contamination response, defining analytical support requirements related to capabilities and capacity, and on-site sample screening capabilities. Section 4 covers safety and personal protective equipment. Section 5 covers preparation for sample collection activities, including sample collection kits and field test kits and instruments. Section 6 covers sample collection documentation. Section 7 covers sample collection procedures. Section 8 covers sample packaging and shipment, and Section 9 provides information about other resources that may be useful to you. Today's presentation will focus primarily on the sections in bold, though we will have a bit to say about other chapters and appendices as well. Sampling and analyzing water that may contain unknown contaminants presents significant challenges. And just to start off, there is the sheer diversity of types of contaminants that you might be dealing with. Consider this list of contaminants, contaminant classes, and parameters. Within each of the contaminant classes, there may be dozens of specific contaminants, each with its own analytical requirements. The sampling guidance provides general guidelines for collection, volume estimation, concentration, preservation, packaging, and shipment for each of the contaminant classes listed here. It also provides strategies for concentrating efforts on the most likely contaminants and covers training and the proper safety practices that are essential to minimizing risks. To increase preparedness, utilities should take certain steps prior to a contamination incident, including these: becoming aware of and understanding your organization's response capabilities, contacting local hazardous materials or hazmat response units and familiarizing them with the layout and procedures of your utility, becoming familiar with the resources offered for emergencies by the CDC's Laboratory Response Network and EPA's Environmental Response Laboratory Network and Water Laboratory Alliance, as well as other members of the Integrated Consortium of Laboratory Networks. Other steps you can take include conducting tabletop exercises to determine how your utility would respond to a variety of contamination scenarios with the resources at hand. And when conducting table exercises, you'll want to be sure to invite representatives from the local hazmat response unit and other response partners to participate and ask for their recommendations and establish lines of communication for use during a response. And information regarding planning a TTX can be found at the URL listed on the slide. All right, Section 2 of the guidance document provides an overview of the recommended level of preparedness for sample collection and screening during emergency response. Depending on the capabilities of the utility, the responses to specific events could vary. The components of the recommended approach include defining analytical support requirements for pathogen, chemical, toxin, and radiochemical analytes, developing on-site sample screening capabilities, establishing sampling team requirements, such as personnel, training, etc., accessing a laboratory support network and establishing a chain of communication for the sampling teams, establishing baseline contaminant occurrence and method performance data for predefined field and laboratory methods, and establishing an information management system. Figure 2.1 provides a conceptual flowchart for the sampling process once a potential pathogen, chemical, toxin, or radiochemical contamination event occurs. The decision-making process is triggered when the utility suspects water contamination. If the identity of the contaminant or the potential contaminant is known, you proceed with sampling and analysis for that contaminant using best practices like you would in any other situation. Otherwise, you gather information that can help narrow down the list of possible contaminants. If the list can be narrowed down, then you use appropriate containers and preservatives for the class of contaminants suspected, and you implement targeted laboratory analyses to try to narrow things down further. If information available does not help narrow down the list of possible contaminants, you collect samples for a wide range of laboratory analyses and conduct basic chemical and biological screenings, and use the results of those screenings as the basis for next steps. Section 2 of the document recommends some resources that can assist utilities in conducting rapid screening and preliminary identification of contaminants. Selected analytical methods for environmental remediation and recovery, also known as SAM. This is a document and a web tool that provides recommendations for which methods might be appropriate for contaminants, and it covers a large number of contaminants. As a side note, some of the laboratory approaches for toxin analysis listed may be appropriate for field use, for example, lateral flow devices. EPA also has a list of SAM companion documents that you may find helpful. And in particular, one of those companion documents is Rapid Screening and Preliminary Identification Techniques and Methods, which discusses procedures to be followed when multiple laboratories are needed to perform rapid preliminary analysis of environmental samples following a Homeland Security incident. Section 3 covers utility roles and responsibilities. Utilities are encouraged to establish appropriate standardized sampling capabilities and procedures as highlighted in Section 3.1 of the document. A utility should establish a baseline profile as described in Section 3.1.1 in order to understand the range of contaminants that exist in its water system under normal operations. This baseline profile is necessary to distinguish background or naturally occurring levels of each contaminant from higher levels that may be observed following a contamination incident. Baseline monitoring should use the same sample collection and analysis procedures that would be used in an incident. This way, the utility should have an idea of what the analytical results for drinking water are under normal conditions. Section 3.2 of the document provides information on various types of incident response sampling teams, utility, local, state, or federal hazmat teams, for example, and the importance of developing relationships. These relationships can facilitate the coordination of the response to a water contamination incident. Skipping ahead a little, Section 3.4.1 discusses identifying sufficient laboratory support to ensure that samples are processed properly and expeditiously. To assist in locating laboratories capable of providing the necessary support, the EPA's Compendium of Environmental Testing Laboratories, or also known as the Laboratory Compendium, provides users with information on laboratories, including technical capabilities, Water Lab Alliance membership status, and contact information. Other resources include your State Water Wastewater Agency Response Network, or WARN, your local EPA Regional Laboratory, CDC's Laboratory Response Network, and EPA headquarters. Utilities are also strongly encouraged to establish relationships with local, state, and federal response partners that would likely be involved during a drinking water contamination incident. This slide highlights the many different types of organizations you might need to collaborate or coordinate with during a response. Jumping ahead in the document to section 5.1, let's spend a few minutes discussing sample collection kits. It is strongly recommended that sampling kits be prepared in advance of a possible water contamination incident and maintained on a regular basis. Sample collection kits should contain all sample bottles, materials, supplies, and forms necessary to perform sample collection activities from a variety of sampling sites, including hose bibs, faucets, or other taps. Table 5.1 in the document, which we'll see in the next couple of slides, lists examples of the basic recommended components for a sampling kit. Some utilities may decide it is appropriate to substitute or include additional items. Utilities should work with their analytical support laboratories to obtain the proper sampling containers and preservatives, as well as to develop an understanding of sample volumes that are needed for the analytical methods that will be used. The example field collection kit provided in Table 5.1 covers field resources and documentation, supplies for general sampling, and supplies that are specific to pathogen sampling. And we will have more to say about sample containers when we get to section 7 of the guidance. Table 5.1 also provides commonly used reagents, some of which may need to be kept separate from the rest of the kit, and safety supplies. It should be noted that when sampling for unknown contaminants, some samples should be collected without preservation because preservatives may interfere with some analyses. Section 5.2 and Table 5.2 list the generic types of screening and detection devices that could be included in either a core or an expanded field test kit. The core field test kit should include the basic equipment necessary to conduct the recommended minimum level of field safety screening and rapid water testing. Additional technologies that might be used to perform expanded field testing are listed in the second section of Table 5.2. Due to the wide range of available field testing equipment, specific devices and vendors are not listed in this table. It is strongly encouraged that users contact vendors for the most current technologies. And it should also be noted that EPA does not endorse or recommend specific commercial products. Okay, so we'll be spending a fair portion of today's webcast reviewing the sample collection procedures on section 7 of the sampling guidance. So I want to start by providing a quick overview of what we'll cover. We'll talk first about procedures for common utility sampling locations, then cover equipment and guidelines specific to pathogens, chemicals, toxins, and radiochemicals. We will conclude with ultrafiltration procedures for concentrating large volume pathogen samples. Section 7.0 includes a call-out box with example sampling procedures for common utility locations, including water taps, fire hydrants, water towers, and underground tanks and reservoirs. Keep in mind that for contamination incidents, flushing times used for routine monitoring may be excessive. Excessive flushing could lead to undesirable loss of contaminants, such as in cases where most of the contaminant slug has passed through the system, leaving only small amounts in various sampling locations. So it is important for samplers to coordinate with incident managers to determine appropriate flushing times. Section 7.1 discusses equipment for pathogen sampling. We see here the list of materials that should be on hand to collect grab samples of water that may contain high levels of pathogens and could also be appropriate for water containing certain toxins and particulates. Section 7.2 covers equipment for chemical, toxin, and radiochemical sampling. These materials should be used to collect grab samples of water that may contain high levels of of chemicals, certain toxins, or radiochemical contaminants or particulates. Section 7.4 covers sample container and preservation guidelines, including typical specifications for collecting samples in each of the contaminant categories. Tables 7.1 to 7.3 from this section of the document, which you will see on the slides that follow, can serve as quick reference guides for collection parameters such as container volume and type, sample volume, disinfection reducing agent, preservative, holding time, and analytical techniques for pathogen, chemical, toxin, and radiochemical contaminants. Since analytical methods are periodically revised, the information on analytical methods, collection procedures, and suggested preservatives may change over time. Available information regarding sample collection for specific contaminants and methods can be found in EPA's Selected Analytical Methods document, the SAM document described earlier, as well as in the United States Geological Survey's National Field Manual for the collection of water quality data, which provides information on the collection of surface water samples. So let's take a quick look through tables 7.1 through 7.3. Table 7.1 describes the sample collection parameters recommended for pathogen methods. As mentioned on the previous slide, users should refer to SAM, the EPA's Selected Analytical Methods report, for current information on analytical methods, collection procedures, and suggested preservatives. Table 7.2 describes the sample collection parameters for chemicals and toxins. And it's one of the longer tables. Table 7.3 describes the sample collection parameters for radiochemical contaminants. And the same collection parameters are recommended for all radiochemical contaminants, which is the reason this particular table has only one row. The last item I want to point out in section 7 is the discussion of pathogen sample concentrations in section 7.5.1. Some pathogens can be present in very low concentrations and still have health-related consequences. In such cases, the collection of a large sample volume may be required. Large volumes of water are generally concentrated using ultrafiltration prior to analysis for viruses, bacteria, protozoa, and some toxins. Ultrafiltration can concentrate up to 100 liters of water to approximately 250 milliliters of concentrated sample. Information about EPA's automated ultrafiltration device can be found on the EPA website. And additional information on ultrafiltration can be found in the EPA National Homeland Security Research Center's protocol for detecting the anthrax bacillus. With section 8, we get into sample packing and shipment. The most important point of section 8 is that all utilities should have staff who are appropriately trained in packaging and shipping for all types of hazardous samples. This section of the document details basic packaging and shipment information for low hazard samples. The appropriate laboratory should be consulted before packaging and shipping high hazard samples. If the hazard level is unknown, samplers should assume that it is a high hazard. In addition to SAM, good resources for packaging and shipping information include the Center for Disease Control and Prevention's Laboratory Information website and the US Department of Transportation Regulations website. Very briefly, I want to point out some other useful information in other sections of the document. Section 4 is a great resource for information on safety and personal protective equipment. Level D, and definitions of level D and other levels are provided in the document, is the most commonly used when sampling for unknown contaminants. In some cases, safety goggles and gloves are optional according to OSHA. However, their use during sampling for unknown contaminants is highly recommended. Samplers should have a quality assurance and quality control program. Section 5.3 provides a general protocol for a QA/QC program. Section 5.4 describes a general protocol for maintaining crime scene integrity in cases where law enforcement is or may be involved. It should be emphasized that interagency cooperation is crucial to a successful crime scene investigation. Section 6, which covers sample collection documentation, also provides a link to EPA's Water Laboratory Alliance Training Center, which offers self-paced training modules on how to properly prepare chain of custody documentation used during crime scene investigations. I want to point out that section 1.1 of the document offers a list of general resources that can be helpful in assisting utilities with developing emergency response plans. and responding to potential contamination incidents. And Section 9 provides links to additional resources that contain valuable information on incident response, sample collection, and rapid screening procedures, including those listed here. And before we leave the sampling guidance, some valuable information can be found in the appendices as well. For example, Appendix C provides an example form for a site characterization and sampling plan to be completed during the initial stages of sampling. This example is quite comprehensive and may be very useful. Appendix F provides an example form for a photograph log, which is not always used, but can be extremely important for forensic purposes. Appendix G provides an example chain of custody form that can be used during sample collection. All right, so as we wrap up, I'd like to say a few words about other resources you may find valuable in addition to the sampling guidance. The Water Lab Alliance team regularly offers webcast trainings on a variety of topics, some of which are listed here. We encourage you to visit the EPA website to find more information about upcoming Water Lab Alliance webinars and to register. These webinars are completely free. They simply require that you register online in advance. In addition, the Water Lab Alliance website has a number of on-demand trainings that you can take advantage of on your own schedule. Now that you've completed this training, here are some next steps you can take. We encourage you to ensure that appropriate staff within your organization become familiar with the sampling guidance document. Prepare sample collection kits, determine where they will be stored and how they will be distributed during an emergency. Establish an approach for maintaining your sample collection kits. Familiarize your sampling teams with the different sample collection methods. Ensure staff are trained on shipping regulations and chain of custody requirements. Supplement your emergency response plans if needed, and connect with potential response partners.